Hey everyone, welcome to Unit 5. We are going to talk about system of linear equations. So when we talk about system of linear equations, we talk about, well, first of all, what I want you to be able to do is to solve a system of linear equations using a table. And then whenever you look at a graph, I want you to be able to solve a linear system of linear equations by graphing. And then lastly, I want you to be able to solve a system of linear equation using system of linear equations using LenSolve. And after we get through with the first two, I think you will find the last one is going to be your favorite. Let's just dig right into this. So we're going to have some problem situations that we're going to need to write more than one equation in order to solve the problem. And so when that happens, we call this a system of equations. Okay, so on the right there you have a graph. You have f1 of x, which is 1/4 x minus 2. And then you have f2 of x, which is 2x plus 5. And then 2x plus 5. All right, so whenever we have a system of equations, it means that we have more than one linear equations. So why do you think we call this a system of equation? Because there is more than one equation. It's a system. Think about even in science, you have systems. It's more than one thing. So this is a system of linear equations. So you have linear equations. There's more than one of them, so it's more than one equation. Okay. So we have some questions here that we need to answer. What do the equations have in common? Look at those two equations. See what they have in common. What are their differences? Okay, now there's an answer between these two linear equations. Where do you think the answer is located? And what is the solution to the system? So I want you to pause the video for just a moment. And I want you to think about those answers real quick, okay? What do you think the equations have in common? What are their differences? Where you think the answer is located, and what is the solution to the system? So pause the video, think about those, and see what you can come up with. There's no right or wrong, remember, this is just a video. We will talk about them when you return. Okay, so some of the things that they have in common. So they both are linear. They're both are lines. They both have positive slopes. They both go up from the left to the right. Can you think of any other things? You could put those in there. Differences, one is steeper. F2 of x is steeper than F1 of x. They have different y-intercepts. Because they're steeper, their slopes are different. Let's see, they have different x-intercepts, meaning they have different zeros. Remember, zeros are where they cross the x-axis. Okay, so where do you think the answer is located? It's at the intersection of the two lines. It's where something is the same. The answer is where something is the same, so it's at the intersection of the two lines. This point right here is the same for both lines. Okay, so the solution, we need to know what the coordinates are for that solution. So on the coordinate plane, if you go over to the left one, let's see if I can do this with this pen. You go over 1, 2, 3, 4, and down 3. This point right here is the intersection of those two lines, and that coordinate is -4, -3. Now, I realize some of you still have trouble with plotting points. We need to work on that. But let me show you how to do this on the calculator, okay? So I already have this graphed over here on the calculator. I split my screen so you could see this. It's graphed right here. So on your calculator, it will find that intersection for you. You're going to do Menu, Analyze Graph, Intersection, and you're going to click, drag, click. So you need to click on one side of this intersection, see the intersection? Click drag it across. Once the intersection name thing pops up, you click again, and it tells you the intersection. So what is it? -4, -3. Okay, kind of like that, huh? All right, cool. So now we're going to go on, and now they want us to complete the table for the given values. Well, what's great is your calculator will also do that for you. Okay, and so if you come back over here to the calculator, remember we can hit Control T, and that gives us a table of values. Well, it looks like it only gives it to you for f1 of x, but it actually does give it to you for f2 of x. You have to kind of come over here and move this over and move this one over, kind of make it where you can see both of them. Now you can see the x value for both f1 of x and f2 of x, okay? And so what we need to do is we need to take this information and put it in our table. Now I have -6, -4, -1, 0, and 5 for my x values. That means I need to go up to -6 and find my x values and my y values for f1 of x and f2 of x. And I think I might have these backwards here. Oh, that's great. Way to go, Miss Brown. All right, so maybe I should fix these. So remember, this should be f1 of x. So the 1/4 f1 of x is 1/4 x minus 2. So this is actually -3.5. Write this instead of type it in there. -3.5. Nothing like confusing you, right? And the 2x plus 5 is -7. Let's see, we have a -4. Come down here to -4. For 1/4 x minus 2, my y value is -3. For 2x plus 5, my y value is -3. It's probably going to be a good thing there. Over here, come down. At -1, my y value for 2x, remember this is, let me write this up here, maybe that'll help. 2x plus 5. This is 2x plus 5. This is 1/4 x minus 2. All right. So 2x plus 5, -1 is 3. And -1 is -2.25. 0 is 5 for 2x plus 5. And -2 for 1/4 x minus 2. And over here at 5, we have 15 for 2x plus 5, and then -0.75 for 1/4 x minus 2. Okay, so what we want to look for whenever we're looking for the solution given a table, what we're looking for is kind of the same thing whenever we were looking for the solution in a graph. We want to look for the common point. This is the common point, right? That's at -4, -3. Well, in a table, what you need to look for is where the x and y value are the same. So my x value here is -4. This y value is -3. So if you split that apart, and then this x value is -4, again, look at this y value, it's -3. It's the same. So we know that this is our solution, -4, -3. Remember, this is the same system of equations. Okay, so let's move on to the next problem. All right, so we have a system of equations, x plus 2y equals 6, and 3x minus y equals 4. Okay, so you know what? These are not solved for y, so we have to do that. So what I want you to do is I want you to pause the video and solve for y, and whenever you come back, I'll have mine solve for y, and we'll see how you do. You need to, you should be good at this by now. Anytime we're looking for slope, the y-intercept, and it's giving it to you in standard form. You should be solving for y. So let's do that. Pause the video and come back and see how you did. Okay. Okay, so now I have the solve for y. So my first equation, x plus 2y equals 6, after I solve for y is y equals 3 minus 1/2 x. So it asks what are the slopes of each equation and what are the y-intercepts of each equation. What's the solution and why is it the solution? Okay, so I need to know what the slope is. What is the slope of this line? Slope is negative 1/2. Okay, and the y-intercept is 3, right? Okay, now the second one, the slope is 3, right? And the y-intercept is negative 4. All right, so we want to know what the solution is. So remember, we can use our calculator over here to find the intersection. So let's do that. We can find it on the graph. Let's find it on the graph. On the graph, I'm going to do over to the right 2 and up 2. So this point should be at 2, 2. We're going to check it with our calculator because it's always great to check things, right? All right, so with our calculator, we're going to do menu, analyze graph, intersection, click to the left, drag across, and click to the right. And there's our 2, 2. And that is the solution. So the solution is 2, 2. And the reason it is the solution is because it is the intersection. Okay. So now what I would like for you to do is I would like for you to complete the table for the given values. Okay, so what we're going to do on our calculator, let's get our table again. And we do that by doing Control-T again, right? We're going to move this over just a little bit. Oh, come on. It's not wanting to cooperate today. All right, and then we're going to start with a -2, so I have to go up just a little bit. -2, -1, 0, 1, 2. Look, everything's right there. And I did actually put it in order this time because my f1 of x, after I solve for y, because you have to solve for y or else it will not do the table for you. It will not do it as a relation, and you can't graph as a relation anyway. So we're going to fill this in. So I want you to do that real quick. Pause the video and fill that in. Okay, so looking at the table, let's see where our solution is. If we look at this table, where's our solution? It should be the 2, 2, right? So at where x is 2, both of our y values should be 2. So yes, this is our solution right here. All right, good job. All right, everything was right here for us, right? All right, so then example 3. So I have this one is in point slope form. Okay, y minus 5 equals 3 times the sum of x plus 4, and then y minus 5x equals 14. But that's not in point slope form, but you know what? We have to solve for y for both of those before we can even graph them. Okay, so I'm going to get you to pause the video and solve for y. Come back and see how you did on those. All right, because you do need to be able to do that. All right, so I'll see you in just a sec. Okay, so hopefully whenever you solve for y, you got y equals 3x plus 17, and then you got y equals 14 plus 5x, or you could get y equals 5x plus 14. Okay, so now it asks us, either one of these works, okay? So it asks us what's the solution to the system. Well, if you'll notice, you can't see it on the graph right here, right? So it's kind of off of the graph. So what we're going to do is we're going to use our calculator. So I want you to see if you can figure that out. I want you to do just what we did on example 1 and 2 as far as the intersection on your calculator and then on the table of values. And then come back and see how you did. Okay, see you in a sec. Okay, so hopefully on your calculator you did menu, analyze graph, intersection, click, drag until it says intersection and clicked again where you got 1.5 and 21.5. So on your table, when you filled that in, when you did Control-T and you found these on the table, what happens is it only gives you it in the x values in increments of 1, okay? And Since your solution is at 1.5, you're not going to find those. So it's in